good day, good day, and welcome to Africa Teen Gig. This is the Digital STEM School. If you have just joined into this class, this is the grade 10 Physical Sciences. My name is Nonkulilego Madondo, and I am your teacher for Physical Sciences. You can see my picture right there in the corner. Today, it is the 7th of July 2020. Oh my word, no, that's a mistake. It's the 8th of July 2020. Today we're going to be doing the molar volume of gases. Today we're doing the molar volume of gases. I hope that everybody is ready for a beautiful lesson. I'm reminding you guys once again that in this class, I usually teach from the Siavula textbook, or you can try also the Study and Master textbook, but any other textbook that you're using that is CAPS approved should have all the information that I teach about. So you should also be on the right track. But if you feel the need to want some more external textbooks, you can nonetheless get them on Snaplified. You can download Snaplified application and you can download all the textbook that you need there. If you have any textbooks that are outstanding or ones that you feel like would make understanding more better, you can download it for yourself and it's going to be free until the 31st of December. Because of the COVID-19 problem, they have, generously given us some textbooks and you can download them there. Okay, they're absolutely free. You can also view them offline. They don't need the internet once you've downloaded them. Okay, so continuing with what we have today, like I mentioned, today we're going to be doing molar volume of gases, and I'm reminding you guys again that in this part of chemical change, we will not be doing reactions in aqueous solutions because it has been removed in the amendment of the ATP for this grade. So, you can just scratch it out. And we're also not going to do hydrosphere. So do not study any of the hydrosphere. Okay. So today, this is term 3. As we're getting ready, soon we're going to be doing assessments. Just a small reminder to you guys. And you guys should be well prepared because right now for term 3, we are doing physical and chemical changes, representing chemical change and quantitative aspects. Okay, quantitative aspects of chemical change is what we're actually doing now, and from there we're going to do representing chemical change. So all of this is part of the term 3 work. Okay, so we won't be doing reactions in aqueous solution. Reminding you guys again that chemical systems has been removed from the syllabus from this year due to the fact that we will be writing one examination, one paper, unlike two like all the other years. So you guys need to take advantage of this and get yourself some great marks and excel in all your schoolwork. Okay, so going back to your homework, I hope that everybody has done their homework. Like I mentioned yesterday, I gave you guys homework, which was remember yesterday we were doing the water of crystallization. Okay, if you remember properly. So this was the homework that was given to you guys. It says calculate the number of moles of water of crystallization in COCl N if the molar mass is 237.9. Okay, and then the next one was the NiCl2 H2O if the molar mass is 165.7 grams per mole. Okay, so we're looking for this in right here. Okay, so basically in this calculation, they've only given us the molar mass of the whole thing. So what does that mean? If you're given something like, remember we did all the other problems yesterday, but we never really tackled one of this homework nature. So if you've done it, great guys, I'm happy. You can just read through to what you've done. So if you've got an entire compound and they give you the molar mass of this, it means that you can find the molar mass of COCl2 in this case. So COCl2, you find the molar mass of that, because remember, if you find the molar mass of this and you divide it by that, you get the percentage of COCl2 on for this entire compound. Okay, so that's why we found it there, 12 plus 5. Here I just put on the whole number according to what I saw on the periodic table, but you can always just round it off to the 1 decimal place or 2 decimal places. So here we are. I found the molar mass of COCl2, and then now I went and looked for the percentage of COCl2, and that gave me 98.01 divided by 237.9, which is what we have there, and we timed that by 100 and it gave us 41.2%. So we're still looking for what we're looking for is the H. So at any case, whatever number of moles you look for, you will need both the percentage, you'll need both the masses for you to find the number of moles. So looking for the percentage of H2O, we said 100 minus 41.2 will give you 58.8. Okay, guys, I really hope you guys have done this homework and you're just reading through what you have already done. Okay, so from here it's going to be COCl2. Okay, now that we have both, we've got both percentages, because here we said 100 minus 41.2 gives you 58.8. Because remember, we assume it's at 100%, and we assume that if it's at 100%, then we'll assume also that it's at 100 grams. So this becomes 41.2 gram, and this becomes 58.8 gram. Guys, I'm also reminding you guys, if there's anywhere where you get confused while I'm explaining, you guys can send me a chat and I'll go back and explain again until you guys are sorted out. So then now we look for the number of moles. Now that we have the mass, it means that we can get the molar mass and we can find what we are looking for. So here it's going to be the number of moles N over M, mass divided by molar mass, and that will be 58.8 divided by 18. Okay, the molar mass of oxygen of H2O is 18, because 1 plus 1 times 2 is 2 plus 16. Excuse me. So it's 1 times 2 is 2 plus 16 in this case, because it's oxygen, and that will give you 18. And there we get 3.27 moles. So now we also look for the one for COCl2, and that will give us 41.2 divided by 98.91, and that should give us 0.42. So remember, here I didn't write a table, but remember I always said it's much advisable to put it on a table. It makes it much easier. But in this case, I didn't. But as long as you guys are following through, if you have done your homework, you'll be able to follow through what is going on here. But if you knew, then I hope that it makes sense to you. So you take between these two, you check which one has the smallest number of moles. So in this case, it's going to be our COCl2, and you divide both sides by COCl2. Okay? And then when you do that, you're going to see that COCl2 is going to be a 1, and H2O is going to be a 7. Remember, guys, you take it, you round it off to the nearest 10. We cannot have a number of moles of 7.4 or 6.75. We take a whole number, okay? So which means that now our equation becomes this. It's going to be COCl2 Obviously, this is a 1 and 7H2O. Okay, so that is how we do this problem. I hope that you guys understood it, and let's do the next one from our homework. Oh, sorry, here I wrote A. I'm supposed to write B. So here it says NiCl2 times NH2O if the molar mass is 165.7. So basically what is happening here, okay? So for this one, the only thing that changes is the NiCl2, but that changes the whole problem. And we've got a different molar mass, right? So here, first, again, we need to find the molar mass of NiCl2. Remember what I said to you guys, is that, okay, I'm just trying to go back. Yes, remember what I said to you guys. I said that if they give you the total number of molar mass for this entire compound, it means that you can find the molar mass of this part here because you've got Ni, you've got Cl, you've got 2. You can find the molar mass. So what you do thereafter, you divide the molar mass of this one with the total number. And what does it give you? And you times it by 100. It will give you a percentage of how much NiCl2 is there. And once you get the percentage of this one, you minus it by 100% to get the percentage for water. Okay? So that's how we're going to do it. And from there, now once we have percentages for each of them, now we can calculate the number of moles. Okay? So here we go. So now we got the molar mass of NiCl2, which is this one. And then now, oh, this is a mistake. Okay, I wrote a mistake here, but what I wrote in here is right. So this should be NiCl2. It's going to be 129.6, which is what we got here, divided by 169.7. Okay, times by 100. And this will give us 76.4%. Okay, then from there, now we can find the percentage of H2O, which is going to be 100 minus 76.4, and that will give us 23.6%. Okay, are you following? If you're not following, send a chat and I'll try and explain again. And from there, now we can find the number of moles, right? So the number of moles of H2O is going to be this 23, because remember it gets converted into the mass, and we divide that by the molar mass of 18, because remember H2O, the molar mass is 18, and then you get 1.31 moles. And for NiCl2, we do the same thing. N is equals to mass divided by molar mass, and that will give us 76.4, which is a percentage we got here, divided by 129.6, which is the molar mass that we calculated there. And that will give us 0.59, okay? So once we get this now, it means that um, we can divide both sides by the smallest number. So we're going to divide both sides by 0.59. And this should give us roughly 1 to 2. So the ratio here is going to be roughly 1 to 2, or approximately 1 to 2, because the 2, we just took it to the nearest 10. It was 2.22. So I took it to the nearest 10, and that should be 2. And that's where you plot it on this in right here. Okay, guys, please. I hope that you guys understand. So this is the water of crystallization problems. Continuing from yesterday, I know yesterday we did a lot of problems, but I hope that now you know how to solve this type of problem, because you know questions, they ask them in different ways and sometimes it gets confusing, but I hope that you guys understand what is going on here. If you don't, drop me a chat. And now I'm moving. We're coming to the lesson of the day. Today we're doing an interesting topic that deals with molars. We're going to do the molar volume of gases. It's not a lot, it's quite short, and we're also going to do the examples of molar volumes of gases. You know, guys, one day, one unit. I want to make sure that there is nothing that is left, no stone left unturned, because sometimes when you move too fast, some people tend to be left behind. But if we spend enough time on a specific chapter, like in one day, then it gives you guys an opportunity to see and study and know all the problems that you can find with regards to that very topic. Okay? So that I hope that everybody is alert. So here, what is the molar volume of gases? It says here, equal volumes of gas at the same temperature and pressure contain the same number of moles or particles. Okay? So if you have equal volumes of a gas that are at the same temperature and pressure and have the same number of moles or particles, okay? So that's how it works. So what is a molar volume? Molar volume is 1 mole of any gas at STP, which occupies a volume of 22.4 dm cubed. Okay? So it means that this is the molar volume. So which means that whenever you get a problem and they say at STP and they're looking for the volume, this is what you're going to have to use. This volume right here. Okay? So it says here, standard pressure and temperature, which is short for STP, which is shorted by STP, means that the standard temperature is at 273 Kelvin, which is actually 0 degrees, and the standard pressure is 101.3 kPa, kilopascal. Okay, so those are the three things that you need to know when it comes to standard temperature and pressure. So that's the standard temperature. It's 237 K or 0 degrees, and the standard pressure is 101.3 kPa. But we also have a standard volume. Standard volume is 22.4. Okay, so how do we calculate the volume of gas at STP? How we calculate it is we're going to say volume is equals to number of moles times Vm at STP. And in this case, our N becomes the moles of gas, the V becomes the actual volume of the gas, which is the one that's either given, it should be given, and Vm will be the molar volume of gas at STP. So Vm is equals to 22.4 dm cubed, okay? So basically, it means that here, whenever you're looking for the volume, you'll always substitute the number of moles and the Vm you already have because it's 22.4 at STP. So this means that a volume of 2 mole of chlorine, which means here you'd substitute 2, and here you'd substitute the 22.4 gas, is 44.8. Does that make sense? And the volume of 0.5 mole of oxygen gas is 11.2, because you'll just plug 0.4 over there, okay? And then we move on. Now we come to a example. So in this example, it says determine the volume of 2 mole of SO2 at STP. So once they give you the number of mole, then you've got everything that you need. All you're gonna do, you just have to um, say V is equals to N times. You're gonna come back to this formula. You're just gonna say V is equals to N times Vm, and your N is gonna be the 2 mole because they said 2 moles off, and your Vm is gonna be your 22.4. So basically, this is gonna give us the same one as this one. It's gonna be 44.8 dm cubed. Okay. And then on number 2, it says determine the volume occupied by 11.5 gram of NO2 at STP. So this one is a bit of a tricky one because here they didn't give you the number of moles, they just gave you the mass. But once you have the mass, it means that you can find the number of moles. How are you going to do that? This is your mass, right? So this is your compound that you're doing, NO2. So which means for NO2 gas, you can find the molar mass. Where do you find the molar mass? On your periodic table. So if you have your periodic table, you check what is the atomic mass for nitrogen. It's going to be 14, and for oxygen it's 16 times 2. So it's going to be 14 plus 2 times 16, and this will give you 46 grams per mole. Okay, so now that we have that, it means that we can find the number of moles. So by finding the number of moles, we're going to say N is equals to mass divided by molar mass, and this is going to be 11.5 divided by 46. Okay, and thereafter moles. Well, what they did here in this problem, I didn't realize that they just I didn't realize here that they just substituted everything in one. But guys, trust me, it's always more advisable for you guys to do it step by step. First, you calculate the molar mass here. This one is correct. Thereafter, you calculate your number of moles. You say N is equals to mass divided by molar mass. This is just to ensure, guys, that if there is a mistake that you made somewhere, or maybe when you type this long number in your question, you forgot maybe to put a 6 and you just wrote a 4, it becomes wrong. So if you divide them into according to problem say now it's the molar mass, now is the number of moles, even if maybe your answer your last answer can be wrong, maybe there will be marks that you're going to get for the number of moles. So that's why it's so important for you guys to do it step by step. Then you calculate the number of moles. After you get the number of moles, then you calculate your volume at STP, and that will be N times Vm. Okay, I hope that it's clear to you guys. If you do have questions, you can send me a chat and I will go back. Okay. So here is another problem, another example. It says here, determine the volume of 2 mole of hydrogen gas at STP. Remember, guys, I told you whenever you see hydrogen gas, nitrogen gas, it means that whatever substance is whatever gas substance it is, it's got a 2 at the bottom. So hydrogen gas, even if they didn't write it for us there, automatically you know that it's a H2 because it says gas at STP. So with this one, it's going to be 2 times 22.4 because they said 2 mole. So this one is similar to the first one that we did. Okay. So here's another one, but this one I think it's properly done. It says determine the mass of 60 centimeter cube of ammonium gas at STP. Okay, so ammonia gas is NH3. So the volume, they said the mass is 60.3. So the volume is given in centimeters. What do we do first? We convert it to the proper standard, okay? So here in this section, when we work with volume, we're talking about dm cubed, okay? So from centimeters to dm cubed, we divide it by 8,000, okay? And then this is what we get right here. It's going to be 0.06 dm cubed. So now we're looking for the number of moles. So which means now we need to manipulate our formula for it to give us the number of moles. So as you can see here, they say V is equals to N times Vm. So we've got the volume and Vm, we always have it. So we're looking for the number of moles. So how do we calculate that? We're going to say 0.06 divided by 22.4. And our number of moles is going to be 0.0027 mole. Okay, so you must always be alert, on how to manipulate what you need for what equation. Okay, so now we come back to the original equation, and that is going to be N is equals to mass over molar mass, because what they're looking for here is the mass, and this is the only equation where you can get the mass on it. So it's going to be 0.0027 is equals to mass over 17.03, and that should give you 0.046. Okay, I hope that we are together and you guys are now understanding how to calculate molar mass at standard temperature and pressure. Okay, it's not difficult, it's just a matter of grasping the concept. Okay, so these are some of the problems that I wanted us to do as well. It says here, choose the correct answer. Molar mass, molar volume, atomic weight, molecular weight, one of the two of a gas is the volume of 1 mole of the substance at its STP. So what is the answer, guys? Can someone send me a chat? What is the answer to this first problem? Molar mass or molar volume or atomic weight or molecular weight of the gas is the volume of 1 mole of the substance at STP. So what is the answer? Remember, this is work that we did when we explained what is 2 at STP. What is the of at STP? Can someone just drop me a chat before we move on? If you know the answer, just send it to me on the chat. Oh, that is great. The molar volume. That is true. That is the correct answer. The molar volume of a gas is the volume of 1 mole of the substance at STP. That is a very right answer. Thank you so much. Um, so going to 1.2, it says equal volumes of all gases at the same temperature and pressure contain the same number of what? Protons, neutrons, electrons, or molecules. What is this one? 1.2. Equal volumes of all gases at the same temperature and pressure contain the same number of anyone, somebody. It's quite simple actually if you think about it, because there's certain things that we didn't talk about so far in this chapter. So it would make it easier for you guys to know which one is the correct answer. Come on, guys. Um, let's move. Let's move. What is the answer for number 1.2? Okay. Molecules. Yes, that is very right, guys. Tino and Noltando, that is the correct answer. It is it is the it is the molecules, because we so far we haven't been talking about protons, neutrons, or electrons, but molecules. So equal volume of all gases at the same temperature and pressure contain the same number of molecules. Okay. So now we move on. It says state whether the following statement is true or false. And if it's false, write down the correct statement. It says here 1 mole of ammonia gas and 1 mole of oxygen gas both have the same number of atoms at room temperature. Guys, is this true or false? Is this one true or false? Okay. Um, let's just see. Okay. So Tino says that this is false. But why is it false? Why is this statement false that 1 mole of ammonia gas and 1 mole of oxygen gas both have the same number of atoms at room temperature? Why do you say it is false? Okay, let's just see. Okay, so, okay, here it is. I'm just going to give it to you. It is correct. It is false because oxygen has 2 atoms for every 4 atoms in ammonia per mole. Okay, so remember now we're going back to the combination of these molecules. So, because oxygen gas is O2 and ammonia gas is NH3. So it says here it's false because oxygen gas has 2 atoms for every 4 atoms in ammonia per mole. Okay. So moving to 2.2. 1 mole of water in the gas phase occupies a volume of 22.4 dm cubed at STP. Is this true or false, guys? This one should make a bit more sense because remember when we talked about the example? Thank you very much, Solutando. This is very true. This is very true. And thank you to Dino. So it's very true because remember we spoke about it. Any 1 mole of a gas is 22.4 dm cubed at STP. So if you had 2 moles of water, it would be 22.4 times 2. Okay. So it says here 12 grams of carbon occupy a volume of 268 dm cubed at STP. Okay. You guys have you calculated? Is this true or false? Is this true or false? Um, false. Actually, it's true, guys. It's very true. Why am I saying that it's true? Because, oh, no, guys, you guys are right. I'm the one who's wrong. 12 grams, it's not 12 mole. Okay? So this one is definitely false. It's supposed to be 12 mole of carbon occupy a volume of 268.8 dm cubed at STP. Thank you guys so much. Okay? So here it says calculate the number of moles of water molecules in 12 dm cubed of water vapor at STP. Okay? So basically here what we're going to do, it's going to be N is equals to V over Vm. Yes, you're just going to manipulate the formula. But if you do have the answer, you can just make a quick calculation and just send me the answer on the chat. Just the answer. You don't have to show me how you worked it out. Just a small exercise, guys, while we still have time. Okay? Just send me the answer of this one. And then on number 4, it says calculate the volume of 50 gram of nitrogen. Okay? So just send me the answer to this one if you manage to get it. Because here we're looking for the number of moles. We've got the volume, but we also have the volume at STP. Okay. So I hope this is what you got. I just don't want us to run out of time or be quiet for a long time. So for here, it's going to be the volume is equals to N times Vm, and the N is going to be the subject of the formula. Then it's going to be 12 divided by 22.4. And this is the answer that we are going to get for this one. Okay. And then here, where you guys see that it says calculate the volume of 50 gram of nitrogen gas at STP. If you've got the mass, it means that you can find the number of moles. Nitrogen gas, remember what we said about anything that has gas? It means that this is N2. Okay, so now you look for the molar mass of N2, and once you get it, then you can say mass divided by molar mass, which will be 50 divided by the molar mass of nitrogen. And after that, then you can calculate, once you have the number of moles, then you can go back to your STP formula, which is this that we got. Okay, so it's going to be N is equals to M over M. It's going to be 50 divided by 28. 28 is the molar mass of nitrogen gas, which is N2. So the number of moles, this is supposed to be N, not M, sorry about that, is going to be 1.79 mole. Once you have the mole, then everything is sorted. Now you're going to say volume is equals to number of moles divided times by volume at standard temperature and pressure, and this will give you 40.1 dm cubed. Okay, so I'm glad, guys. Thank you guys so much for participating and all the problems that we did. You guys clearly know what you're doing and you understand this work, and I'm so happy. So this is our homework for tomorrow. Okay, it's not a lot, it's just easy stuff. You already answered the difficult stuff, so which means this will be nothing to you, but it will be good for you to just practice on it. Okay, so if you guys can just do these problems for me, say calculate the volume at STP of 1 mole of oxygen gas. Remember, guys, don't forget what I said to you guys about these gases and what they actually mean. Okay, so thank you guys so much for a beautiful class. My name is Nonkululeko Madondo. I am your grade 10 physical sciences teacher, and we have reached the end of our class. Okay, should you have any query, you can get me on t33tndlovu@gmail.com, or you can add me as a friend on LinkedIn, as a connect on LinkedIn, as Trio Matondo, and we can chat and you can show me all your problems with regards to physical sciences and what we are doing for term 3. And guys, please make sure that you don't ever walk out of this classroom without anything that you don't understand. Because if you don't, you can just simply send a chat and I can explain it to you. Okay? Thank you guys so much. Have a beautiful day and goodbye.